Hello and welcome. Day two of Azure AI Connect. Thank you everyone for being here today as well. We have Elad with us. Uh, Welcome Elad. I will bring you on stage in just a moment. I want to verify your session name, Accelerating AI Success, Leveraging Scalable and Cost-Efficient LLMs with Azure. So far, we have seen interesting presentations. I bet one of them is Elad's as well. So, without further ado, I'm bringing Elad on screen. Hello, my friend. How are you
Hello,
today?
great, nice to meet you.
Nice to
I'm a
meet you, Elad.
different time zone, so it's early in
I
the
bet.
morning.
Yeah. Where are you calling from?
From New Jersey, so here it's
New
9 a.m.
Jersey. Yeah, yeah. Very nice. Uh, you can bring your screen online, and we will see that everything is all right.
Of course. Let me know if
I
it's
will
okay.
add it to the stage. Yes, perfect. So, Elad, the stage is yours. Um, Thank you for joining.
Thank you so much.
You're driving.
Hello, everyone, and again, I'm really excited to do this session and in this amazing conference. So we're going to talk about how to leverage scalable and also cost-effective LLM with Azure OpenAI. And before starting it, I'm still thinking about maybe for us as a developer, as a DevOps, let's just look at it as okay, so we have another API that we need to call. Sometimes the API will go to a backend service, sometimes it will go to some kind of LLM inference. But what's the hassle? It's just another API call. So let's try to manage it if we need to do it ourselves. So, what do you think will be the cost of running inference for a popular LLM? And when I mean popular LLM, of course, we have a small models that can run locally, but I'm talking about large language model, which is state-of-the-art foundation models like ChatGPT, OpenAI, and other models like Cloud 3.5. So, what's going to be the cost if we need to run it ourselves? Let's take example of requirements running in production and a simple one. Let's say that my input, the number of tokens that I want to submit is around 8K, and the number of tokens that I want to get as a response in around 4K, which means a small offering of large language model because as we know today, it's much bigger. The model itself will be based on NVIDIA model called NeMo 43 billion GPT. The first token latency that we are allowing for us to get for our users is around 3 seconds. This is the maximum amount of time we will wait for getting the first token as part of the response, which is okay, but sometimes we get even lower than that. And of course, the number of prompts, maximum prompts that we need to support in order to support concurrency, in this case, is 31 requests. I think that we're missing something here. In order to run it, we know that to do the inferencing itself, we need to load a lot of information based on the GPU memory. How are we going to do it? So at first, we need to calculate how much is going to be the hardware itself. The solution, this kind of case study that I show you, it was published, I think it was 6 months ago by lab of NVIDIA, and they show how they implemented it with their model. So the solution is based on a GPT-3, 175 million billion parameters, which is GPT-4. This one is smaller, as we see. It was around 50 billion parameters. In order to run this model, they're required to run on DGH 810 that served 2.4 requests per second. We need to add more. So the calculation getting also 2.6 latency for the first token response, which is fine as we defined 3 second maximum. And the inter-token latency, the wait time from token to token is going to be 21 millisecond, which is great. And of course, the maximum amount of time for you to generate a complete response, let's say around 500 tokens, is going to be around 10 seconds, which is high. And even with this model, we're still talking about 13 DGX H10 system, which is quite a lot of spend if we need to have it as part of data centers that we develop ourselves. And to summarize how much it's going to cost for us, Let's take a look on this example. The hardware spent on this system will be around $500,000, and this is 1 year's spend. But again, every hardware that you are setting up in your own data center, you still need to pay for electricity, you still need to pay for maintenance yearly. So the cost of the first year is going to be around $6.5 million, but the ongoing is going to be also a lot of money. So running this model is not just an inferencing. Even if this burden is shifted into the cloud providers, there's a lot of aspects that you need to think about it. So when you think about frontier models like GPT-4 and others, uh, the time and effort taken to this company to train this model and also do the inferencing is quite a lot. And it's going to be shifted also for us as consumers. And this is why we need to focus also not just about the performance, but also about the cost. So based on a report called AI Index 2024 conducted by Stanford University, the estimate of cost for training the GPT-4 was about $78 million. And getting a new model, I think it was around maybe 200 billion parameters. Gemini Ultra cost around $191 billion. It's quite a lot of money. And again, this is only paying the price for the training and not the inferencing itself. As we saw, the inferencing itself going to quite a lot of money to ensure that the current concurrency that we need to serve for all of our customers. My name is Elad. I'm a tech lead at TerraSky. My focus is basically on public cloud in the last 2 years, offering LLM operations to our customers. I'm a tech advocate and I've been a software architect for many years. And again, thank you so much for this opportunity. When we're talking about Azure OpenAI services, it's really, really easy to just start a new endpoint. We get a deployment. When the endpoint, we have the URL, we have the authentication tokens, the bearer tokens that we need to use. It's quite simple. So basically, I'm going back to the questions that I said. So what's the hassle? What we can do? I think that the first question we like to answer is to understand that even though that we have a specific range of models that we can use, every one of them can fit to a different case study, a different business challenge that you want to solve. So the first thing that we come in mind is not just creating a new endpoint, but rather start with the problem itself. Start with understanding what is your requirement, not just, okay, I just want to use this shiny new tool called AI or AI agent or anything related to that, but start with the understanding of what is the problem it's trying to solve, and then starting to work with evaluation of the models and only then serve them. This is the basic stuff. Another thing that we're looking when we speak about models is that the understanding that we all started with ChatGPT and OpenAI. And to be frank, all of us used just copy paste data into the ChatGPT. And sometimes we didn't thought about the concerns of data privacy. Do we have any data leakage that we're sending information that's sensitive? It need to be intellectual property of a company that not be shared by third party like OpenAI. So we see customers in the last 2 years shifting from ChatGPT and OpenAI offering into Azure OpenAI offering. And let's discuss the basic statement of Azure OpenAI about your data and your privacy. So at first, it's not available to other users. So every token that you send in and every token that you get a response from the model itself is not will be used by any other customers. This is a basic statement for them. It's not going to be available to training back into OpenAI for the model. It's not going to happen. It's not going to use to be improve the OpenAI models itself. And it's not going to use to train, retain, or improve the Azure OpenAI services, okay? Because Azure also have their own models, LLM models. It's not going to be used. The data will be private to you. And just to continue, it's not going to be used to any third-party product and services. All okay. It means that the first thing we're going to ask ourselves, if we have an implementation currently on ChatGPT style, and again, it could be your users running it in the UI just to get a response. It could be an agent that you develop that calling ChatGPT throughout the API. We see a shift from OpenAI to ChatGPT, and from ChatGPT to Azure OpenAI. Again, it's starting because of privacy. It's starting because we see products that are moving from playground, inception, incubation, beta into production. And when it's come to production, everything related to the data itself is something that you want to protect. Another thing is talking about the cost, and the basic element when you're talking about this about cost in LLM is about tokens. So as we all know, we are sending um, plain text into our model. This plain text is used to tokenize by an LLM model that specializes in tokenizing my input. And this is an example as we see. The way that the model is, the way the basic model, the serverless model, the service that we pay per token in and out, is basically in the number of tokens that we're sending. And again, it's not just it's also the concurrency, and there are rate limited, and it's really depend on the models that you're selecting. There are different price range per tokens. Most of the time it's per million tokens. But again, this is a very foundation thing. You're taking your plain text, it's split it into tokens by the LLM models that specialize in tokenizing your plain text, and this is the cost you're getting. This is simplified version. So the questions that we want to ask here is which model we're intending to utilize. Because again, the typical number of tokens that the input sending to your that you're sending to your model, it's not just the text that my user is sending, for example, in ChatGPT or any other applications. When we're sending a model, when you're sending a prompt into the model, as we all remember, the model itself, when you're getting the request, it's a stateless operation. You need to get all the context every time you're sending an information. Even though you may have features like history and you have agentic memory, again, all of these are still just one context that you're sending with a lot of information. For example, here you have a system prompt, you have a user prompt, you have the context. Maybe you're also attaching a knowledge base. But at the end of the day, all of this element is as part of the prompt itself, sending every time that you are sending a request into the LLM inference endpoint. And if you're talking about the cost and the number of tokens you want to send, you need to think about all of this part of the token itself in order to make sure that the pricing is right. Another thing is to understand that, again, this is like, it's not 100% accurate, but just to make sure that we understanding, it's approximately, let's say, 75% of the word for a token. Again, we'll see a much more better way to solve it. And again, also, you need to think about the average token count in your LLM output, because as we understand, we build not just by the input token, but also the output tokens. And of course, another thing when talking about LLM is to understanding how much requests per seconds we are sending. As we said, it's not just about the cost, but it's also about rate limit. We saw a very big customer of us moving from ChatGPT to Azure OpenAI. And when he started working with Azure OpenAI, he started with a lower commercial and not the enterprise one. And he very easily got into a situation where he got the rate limited. So what he created more accounts and more accounts just to get more capacity from the Azure OpenAI. And this is, for example, something we call PTU that we will discuss in a bit. This is something we need to understand when you're moving from just playing around with ChatGPT, Azure OpenAI, and production workloads. And another very important thing is about the latency. As we show you before with the example, the NVIDIA example they done internally and shares the publication, waiting for a model for 3 seconds, it seems like quite maybe a higher threshold. And also, if you remember, for example, getting a response of 500 tokens in 10 seconds, again, this is too much. So you need to also benchmark the model and make sure that the response times can suit the, let's call it, quality of service that the user are accepting for your application. As we said, getting the tokens is really nice. We can take the equation of, like, as we said, 75% of a word and multiply it by the number of words that we have. But we have a very cool feature, not cool feature, but library, and this is one that you're using here, called Ticton. Ticton, you can give the model encoded text that you want to send as part of your prompt, and again, including everything: the context, the system prompt, the knowledge, and the actual prompt that the user sent, and you will get response about how many tokens it thinks it's evaluating to be sent into the model. And then later on, you can use it to evaluate how much money you're going to pay. This is very basic, but really nice. And keep in mind, as we said, everything count as a token. It is a stateless operation. Everything need to be sent as part of your request into the LLM prompt, URL. It's a system prompt. It's a RAG if you have any context and you retrieve it. It's a chat history, anything there. Another feature which is really cool about performance, but also about cost, is your ability to stream the data. Another, this question you're going to ask yourself is that, do I need to get only the final result, or I can stream the data? And here, if you can see, this is an open API, and you see that you're using the very famous chat completion create. You're using a specific model, but you're getting the response in chunks. So sometimes, in order to improve the latency, and if this is something that can really behave like, let's say that you are building a chatbot. In chatbots, the user experience will be okay if you're going to send it word by word and getting some, as we said, like very low latency between each word. This is going to improve your performance because, again, the response is going to be getting like, first of all, maybe have like a bigger time latency, maybe as we said, like between 1 second to 3 seconds, but then the latency between them will be like 20 or 30 milliseconds. So it's quite nice experience, and I think it will be fits for most of let's call it chat styles applications. And again, if it's not needed, you can use it without streaming, but again, it's going to be Boolean. You're going to get the complete response, you're going to parse it internally, and only then you're going to send the complete answer to the customers. And again, sometimes it fits, sometimes it's not. Going back into the rate limits and how much, let's say, how much tokens and how much rate limit can I supply to my customers. In order to do so, we need to understand three terms when it comes to this concept. One of them is TPU, which is the token per minute. And this is assigned, let's call it a hard limit for the rate limits of your deployments, which means the token per minute that you get, if this is a provision that you get as part of, as it said, the model itself, as part of the license that you have, the commercial license that you bought, this number is the high-end threshold that you're going to get into the users. If you need more, you need to think about upgrade to higher, let's call it commercial offering like enterprise, or add another subscription and add another endpoint, and you will get more rate limits specifically for the new endpoint, and specifically if you're going to get new account as part of your organizations. So as we said, it's a token limit. And this is really nice when you are working pay as you go, which means you just started, you don't know how much scale it will be, and you just pay as you go. You're just starting small, and if you need more, you're going to get more. And again, till the threshold, which is then you need to think about other concept. The RPM is a request per minute. They call it CPM, 6 RPM. It's most of the time it's calculated per 1000K, and this is eventually the rate limit based on the request. This is something, again, as part of the cap, as part of the cap that you're getting for each accounts. But again, it's not directly billed. And the other one, which is based on a commitment, is the PTU itself. The PTU, which called provisional throughput units, it's a reserved capacity. It means that you're buying a reserved capacity from Azure OpenAI, and it gives you consistent workloads over time. But again, it's come both ways. If you're going to buy it and not use it, you're still going to pay for it. And what we explore right now is the way to understand if I need to go with a PTU or pay as you go. Let's see two of these examples. As we said, pay as you go, it's a variable cost. It's usage-based, can have peaks, but it's capped throughput. You have the latency. It's defined in the documentation, and it's something you cannot change by negotiating with them. You need to change, as you say, you need to buy to add more accounts, or you need to upgrade into a higher subscription level. And it's good, as we said, like it's good for sandbox, low environment. It's not for high scale production because it's still you don't going to get any assigned latency. When you're talking about PTU, First of all, there is a minimal amount of PTU that you need to buy. I don't remember the number right now. I will share the information later on, but there is a minimal number of PTUs that you need to buy. You're getting a scalable and ensured throughput, and of course, your sun latency. And it's very good for high production workloads, volumes, throughput for heavy workloads. And again, you're also going to get discounts because if you're buying PTU, you can buy it and pay ahead of time, and you get substantial discounts for the price that you're paying as pay as you go. So I think this is giving you some kind of, like a very high estimate about when to go with pay as you go and when to go with the PTU. But I think that the next question you're going to ask me is, okay, how am I going to estimate how much PTU I need? So let's talk about, like the best practices. And again, we're going to explore tools how to really estimate it. So you need to analyze the patterns of your behavior. So let's say we have a company, we have like 3 chatbots, we have some kind of, like other users that's consuming from backend service. We need to monitor the relevant metrics from OpenAI ChatGPT in order to make sure that if we have a consistent workload, we have peak use, we have a peak use based pattern. We need to implement a spillover or understanding if we need to handle a burst strategy to handle surge efficiently. Also, we can use, and this is what we're going to see, we're going to see that we can use the historical data using the Azure OpenAI calculator or capacity calculator to get the estimate PTU. And of course, if you want to simulate it, we can simulate traffic and we'll show you how to do it with an open source project. So let's start with Azure OpenAI Studio Calculator. So if you have the data, if you have the number of peak calls per minute that you need to support, and you know how much tokens you're sending in and how much tokens you need out, this is really simple. All you need to do here is that to give a list of all the workloads for each one of them. And again, keep in mind and read it carefully. It's a peak calls per minute. So again, sometimes taking a very high peak calls per minute can be something that you really want to address in production, but it's going to cost you a lot of money. So try to make sure that the numbers that you're getting are accurate to the reality of your production workloads. So by giving this equation, the peak calls per minute, the number of token in, and the number of token out, you can have when you click here on the play button, you're going to get the estimate amount of PTU. But again, in order to do so, I need to understand what is my peak calls per minute and what is my number of tokens in and out. And in order to do so, there is another project, very cool one, called Azure OpenAI Benchmark. You can run it. It's just a Python code. You run it from the CLI. And as you can see here, I'm running a benchmark, a load benchmark. I'm selecting the model itself. For example, here it's like GPT-4, the concurrency rate, the retry, because I want maybe to make sure that I'm not just testing in flat. I want to do it exponential, which means I will start very, very low in RPM level and go incrementally in not a linear base, but exponential rate. And as you can see here, it's running. It's going to tell you how much tokens it sent, how much token is going to get response. And it's going to give you very, very nice information about when it got reached by throttling, API pushed him back and said, okay, I cannot run it. Then he also simulate a retry backoff with like some random threshold and run this again. And you get more, let's say, realistic simulation of working in a stressful environment. By the end, you're gonna get a response about how much you think, how much like concurrency can be supported by this model at this rate, and you can take this information and run it through, as we said before, the OpenAI Studio Calculator. But again, this is a simulation. I'm running in production. Can I get this information from running just my workloads in Azure OpenAI? Yes, you can do it. There is metrics that you can use. For example, prompt token metrics. You can get these metrics. You can get the number of tokens that you're returning. It's going to be splitted by the modality that you're running, and you can use this information for later on evaluate. Also, if you have some study workloads over time, and you maybe can buy PTU, but also the information to calculate even worth to you or not. And when we're talking about these patterns, this is, I call it, are you joking pattern. Okay, barely in even like the simple organization, it's not going to be like this. And again, this is so easy because I see that this is my traffic. It's like I have this number of token per minute that I'm sending, and it's not token, as we said, like it's needed the number of requests per minute. Then in order to make sure that I'm okay, I'm only need to buy a PTU over 1 unit above, and I'm going to be okay. I'm going to get all the information. I can buy it ahead of time, get a discount, and make sure that my quality of service to my users is going to be static. It's going to be okay all of the time. But it's not reality. In reality, when you estimate a PTU, it's going to be changed over time. And you need to think out where you draw the line. Where do you draw the line at the number of PTU? Because if you got the threshold so high, okay, it's going to be great. But every time you're going to see this part, okay, it's going to be waste. Okay, sorry, this one is going to be wasted because you are meant to use a capacity which is higher barrier, but again, it's going to cost you much more time. Take a look of how much time you waste here. And again, in this higher threshold, when you have the peaks, of course, this PTU will serve you quite good. And again, it's okay to decide it. It's okay to decide that I need to be at the max level. So even if I have one case of some kind of peak, I will handle it without any disruption to my users. But again, it comes with a lot of cost, and the ratio of the waste time is getting even higher. So again, we see two customers. One of them is taking into the baseline. No one is taking to the lower end because again, we're working in production. And we see some other customers that tell us, okay, we're gonna get this money. When we thinking about how we price the model, we taking into account that we will serve you with a higher level of quality of service. And again, it's okay that it's going to cost a lot of money. Maybe it's okay that we have a lot of time that may be wasting the time, but this is part of my commitment to my users. Another thing is about multiple environments. Is it even the case? Do we have any case that we need to support multiple environment? Why not just go to US region, just spin up an endpoint and serve it all my clients? Is there really a scenario that I need to support a multiple environments? And of course, when talking about multiple environments, it's mean multiple endpoint of the different regions that we need to support, and deployment and different endpoints that need to be managed separately. So it's recommended at least to create two separate subscriptions. One will be for production and another one will be for QA. So even if you don't need to serve, let's say, other customers or have your other situations that we discuss in a second, you still need to separate between production and QA. Keep in mind, as we said, the rate limits and the quotes that you get from Azure OpenAI is limited, especially if you're not buying a PTU or you are in a higher tier. So running a QA under the same production endpoint and just abusing the API will be a devastating solution to your production. So at least separate the subscription, because as we said, the rate limits is based it's defined based on the subscription. This is something you need to address and understand. The second one is you need to share, you have a permission, like separate permission for each environment. I think it's self-explanatory, nothing to add here. And also you need to configure a distinct AI service request tailor for different deployment models, because keep in mind, it's have different latency, different cost, and of course different SLA. You're gonna get a different amount, for example, of rate limiting and number, as we said, number of requests per minute. If it's let's call it like O3 or even other more advanced, it's going to cost much more, and you get the rate limit is going to be much lower. So you need to understand that the models that you select are really specific for and tailored for the use case that you want to use. And of course, don't mix and match between them. And of course, when you're talking about pay-as-you-go deployment, it's really nice for development, and maybe it's a good idea to think about PTU when you're coming into production. And again, improve billing by have a budget control, etc. But you all know it. But there is another case. Another case is when you want to set up multiple locations because of maybe regulations. Let's see some use case. The first one is regulatory. As you know, there are highly strict regulations for Europe and also for California. And the best way to separate resources group for each region, because of this kind of regulation, is to do so with a resource group that is different for this region and another region. So when you think about it, maybe it's reasonable that if we're talking about the production workloads, maybe we have more than just one endpoint that we need to manage and handle. How it's going to reflect our daily operation as DevOps engineer? It is something that now I need to manage like 20 accounts and subscriptions. Do I need to get metrics from different regions on different resource? Do I need to handle a quote limit for each one of them? It's going to be a bit of hassle. How are we going to do it? So another example is for disaster recovery and of course for performance. This is where APIM shine, and I really love this product. And they invested a lot of time to make it even more amazing when it's come to specific features that are more relevant to serving our LLM inferencing as part of, as we said, like as part of our customer journey and development. The GenAI gateway, which is APIs in the center, as you see here in the solution, is setting up a core component where every time a consumer, backend application, the UI need to get and interact with an LLM, it will interact via the APIM. And everything related to managing multiple endpoints, caching, security, performance, monitoring, it will handle seamlessly by the APIM. How it's going to work? It's going to work because the gateway solution give you very nice features. It could be handling quotes. It could give you, as we said, like a unified API. It can give you some kind of policy to understand that specific request will go to a specific endpoint. So, for example, if you have, and we show this example in a second, if you have some kind of a header as part of the HTTP request into the APIM service, he will understand that this is maybe not a production. I need to go to this endpoint and this deployment and not the production one. A lot of features. Let's take a look at a very simple pattern. This is a single region. We have a very basic setup, but however, even this in this very simple architecture, it could scale into much more resources. Take a look here, what we see here. We see that we have the users. They have an enterprise AI application, any application. They are connected privately throughout a private link channel into the APIM. The APIM then have also private links into two different Azure API endpoints. Take a look here. One of them, we have a PTUs, another one, we have a TPM. And based on the workload, specifically the workloads, it will reroute them into the specific endpoint. So we'll make sure that even though that we have like, let's say, for example, this is a single region, and we have one for production and one for non-production environment. This is going to be very easy for us to manage. Another concept is this example, which is too many requests. As we said, the request per minute rate limits is enforced. This means that you have rate limit that you cannot exceed. And it doesn't matter what you do, you cannot exceed it. But even when we have too many requests, it's not like okay, we cannot do anything. In a lot of time, the solutions that you have when you have too many requests, it's just to have a pushback and have some kind of random latency, and retry running this request after X amount of time. In order to do so, you can develop it by yourself. So, for example, this is again the SDK, ChatGPT completion. We're running it, and as part of the exception, if you're getting thrown exception called rate limit error, we're going to do some kind of, like here it's not randomized. This is really simple example, but you will run it again, and there is a good chance it will run. So it's not like a exponential backoff strategy, but there is a good chance that even with this very simplistic solution, it will run again and to be okay. But again, this is just an example. It's not something that we use in production. So I need to implement some kind of exponential backoff algorithm. But in order to do so, do I need to really implement it again and again and again? No. So what's really nice, you can have a policy. And as a part of this policy, if you're running it and the policy are XML, retry, given the condition, and I'm saying that if I'm going to get this kind of status code 49 or this kind of which is less than, so in this case all this range of HTTP response code will be for us a condition for a try, then run a retry, this interval, this delta, and the maximum intervals that you're going to wait, and the number of retries that you're going to say that after that I'm not going to run try it. And now you have the exponential backoff implemented at the API level. So you don't need to do anything. So you will use it to retry the logic and without rewriting your code again and again. This is really, really nice. Let's take another example. This is a the multi-region one. As we show in a previous slide, in a single region scenario, we have API-M. It will be used to queue and send prompt to any OpenAI endpoint. And again, it could be split between production and production. But as long as this endpoint can be reached, we'll be okay. But when thinking about multi-region example, we have two endpoints, but it's going to be in two different accounts. So do I need to manage multiple API-M? No, I can still have one API-M centrally. It will have distribution endpoints across many other regions. But again, I still have one management cockpit for every operation. And as you can see here in this example, I have the same thing as before, but now I have another endpoint, which is reroute to this. And again, this is private link to a specific subnet that expose. And of course, we have a VNet peering because it's a multi-region scenario. But again, it's the same operation. And based on the rules that you're writing here, you're going to get the specific workloads rewrite, reroute into the different region. And again, why I need to do so? Even with the simple thing, I have a US customers and European customers, and I want to make sure that I'm complying any regulations based on European one. Just this is for example. And again, as you see here, it can be splitted. One of them I will have a TPM, which is pay as you go, and some of them I have PTU if I need to go in production environment. And again, how it's going to work? It's going to work by API-M rerouting based on a specific logic that you're writing as part of the XML. And let's take, for example, round robin. How are we going to implement it? A very simple one. Take a look here. It's very self-explanatory. You have to choose, and this is where to route, based on when, which is the condition itself. So this is my backend counter, okay? This is where I'm managing my round robin. And again, round robin, how to split evenly between all the endpoints. And as you see here, if I'm taking it a model, if it's 0 or 1, I know that I need to rewrite to backend 1 or backend 2. And again, without any disruption to my logic. Of course, this is something you expect to see in any load balancer or API gateway, but this is really something that can easily achieve in API-M. What are the best practices when we're talking about API-M? First of all, is to understand the HTTP response code. So every time that you're getting 424 or 492, you understand you need to do some kind of exponential backoff. Or again, you can send exception, but again, this is a very good approach, specifically if you know that LLM resources are scaled, and which means that sometimes you're going to get into the rate limit, but it's okay because, okay, you're going to get some kind of random exponential time, but when you rerun it again, there is a good chance it will be okay. There are some more response code. I think that most of us know it, and there is nothing to say here. And of course, you need to understand the token limits for the model. It's a different per the model, sometimes per regions, and of course, it's different if you are in a different tier of customer tier, if you like, an enterprise program or an LL program. This is really different. And of course, the model itself. And of course, you can use auto update to default models. So in case that, let's say that the models that you're using is as we said, is not available based on getting to the limit of the model, maybe you can delegate it to another default model. Maybe the response will not be accurate as your main model, but it still you can serve your customers. And of course, we talked about pursuing PTU. We're talking about support for multi-region with API-M. And of course, I think that another thing which is really, really nice is keep in mind that again, the rate limits is per subscription. If you have multiple deployments, you need to think about how you manage the capacity between them. So, for if you have a production model, maybe you want to give them more a quality of service by giving more capacity that you can run, which means more mass token and best of it. But if it's non-production, maybe you can lower the bar and it's going to still be okay. Maybe you're going to wait a bit, but again, it's means that you need to use a quote management mechanism to allocate the TPM across all the deployments. Okay, so keep in mind if you do so, you have to do it. And again, keep in mind that if you're buying PTU, it's based on the subscription that you're running on. You cannot share it with other subscription. This is something you need to understand if you're buying the PTU. Performance-wise, I think that when we're talking about performance-wise, this is something that we got from customers that we see going into production. Don't mix between different applications using the same endpoint. It's going to negatively, of course, affect your performance and latency. If the model latency is very important to you, you can try using your, like a lower model, like not very big, but the latency will be much lower. So, for example, GPT-4. So as always, you also, as always, you need to think about the balance between cost, performance, and quality. And as we know, in most of the cases, you can only choose two. But again, this is something like an endless operation you need to do, like running the model again and again and again, and make sure it's okay. Make sure you also okay with the cost, performance, and also, of course, the quality of the response. And of course, the fewer tokens generated, the faster overall response time. The time that the latency is not just taking your clear text, it's tokenize it, sending it to the model, and wait the time for the model, for the endpoint, sorry, so inference endpoint to respond with the complete response. And again, it could be token by using a stream mechanism. But again, if by the end of the day the response is like the complete text, this is latency itself. And of course, as we discussed about, you need to understand about limits, quotes, previews, and latency. This is one example. Take a look here. The O1 enterprise agreement has 60,000 K TPM, and this is a number of requests per minute. This is different if you're not in the enterprise agreement. So keep in mind that this is something you need to understand, that sometimes you need to go to an enterprise agreement if you need much more higher quotes per subscription. And of course, you have this is something new, that you have a self-service quote request that you can zero count quotes and manage them based on your requirements. RAG performance benefits. This is also important. Okay, when you think about it, every time that you need to tokenize your data, your click test data again and again and again, there is still penalty, performance-wise and cost-wise. So if you going to send a lot of information, you need to retrieve information, why not using RAG to retrieve that information? And it's going to cut your pricing, but also it's going to give you much more faster response time because you already retrieving a pre-indexed data quickly and you don't need to tokenize it again and again. And of course, this is going to scale to much larger data sets. What is the get next output token? How it's going to work? And this is something that's super important to understand the performance. As we said, when I'm running my query as a plain text, first of all is do the tokenization. Then it's going to do initial prompt processing. This is a pre-fill part, okay? When I'm doing the decoding of the data itself. And then, only then, I'm doing after it's running on the LLM agent, I use the did tokenization and show again the plain text in ASCII format. You need to understand that the time for the first token, it is complete process. So if we're going back, lowering any part of this, it'll be boosting our performance. And again, this is like a simplified version of it. Let's talk about the embedding process itself. Sometimes we can do it ourselves. There is a text embedded 3 small embedding model by OpenAI. You can use it, embed it, keep it in a very simple data store, and retrieve it, even without using any fancy RAG solution. This is what it is. But also, this is example how it looks. Another very nice feature is the semantic caching. Think about it. What is the chances that my users, sorry, are sending the same prompts again and again and again? There is huge chances that it's going to happen. First of all, most of the time when my user is sending this information, it's sending it via some kind of a chatbot, API, or any other solution, which is hidden the system prompt, hidden the context, hidden the user query. And a lot of these patterns are repeating again and again and again. When you enable semantic caching in APIM, what it's going to do is it try to figure out the different parts of the query that's been tokenized and used again and again and again and keep it in storage cache, like Azure Cache for Redis. And every time that we're going to get this hash based on this token, on this data that he understood, he already tokenized, instead of calling, as we said here, instead of calling into OpenAI, for example, embedded API, it will just retrieve it from the cache. So this is really nice feature. And as you can see here, this is an example of the policy. I'm getting some threshold. I'm sending it to the backend, Azure OpenAI embedding backend ID. Of course, the embedding authentication mechanism pointer, and of course, the subscription ID. And what you're going to do is going to look first on his semantic cache lookup, which is, as we said, can be cache by Redis. And only if it's not there, he's going to send it into, as we said, embedding backend API. This is another example. And as you can see here, this is example took by benchmark from Azure OpenAI team. And as you can see, over time, of course, the first time we need to learn the data, we need to see a lot of new, let's call it prompts that we're sending. But eventually, over time, we're going to see that the different amount of data that we're sending and need to be tokenized again and again is quite small and steady, as we see here. The last thing, as I said, is multiple models. And with this, I would like to conclude the session because there is a lot of other information, but I think this is a good time to let's try to ingest what we discussed so far. When we're working with models, as we said, we need to start with a business problem. We don't need to start, we have a shiny tool. And it makes sense that we use different models for different case studies. By using the Azure OpenAI, we can have one region where we have GPT 3.5 Turbo for a specific use case. And I will have another endpoint specifically for GPT and another one with GPT 4.5, the new model, for example. And my APIM, based on specific headers, based on specific IT, based on specific deployments, whatever routing policy you define, we're able to seamlessly send a request to appropriate model. And to do so, I'm just going to give you a very simple policy snapshot. Take a look here. Based on a header that we have in a request called deployment ID, I will understand that if the case is GPT Turbo, and this just an example, I will go to backend 1. If this case, I will go to backend 2 and forth in any other cases. And of course, if I have no header, I will just route it into the default backend 1. This is give you, again, the core component managing a production workload when you have different quotes, different compliance, different performance requirements, and different applications. Using APIM as a core solution is great. And we didn't talk even about metrics and cost billings. There's a lot of other aspects that you can use, hopefully maybe next time. Thank you so much for your time. It's been a pleasure. My name is Elad, and you can reach me in LinkedIn. I would love to chat with you guys about your challenges, about new stuff that you're doing, about any other challenge that you have with Azure OpenAI. I'm quite eager to learn from you guys as well. Thank you again for your time.
Wow, that was amazing. Thank you so much, Elad. It was one of the most interesting presentations I have seen, very deeply and technically solid. I really would like to have the time to discuss more things with you. I had a question.
Yeah.
So, at some point in time, you said that, and correct me if I'm wrong, okay? You said that it matters which SKU we're choosing in the EPIM. Is that correct?
Can you repeat? Sorry.
It matters which SKU we choose in API management. I'm summarizing it a little bit. It is
It,
important to select the correct SKU for API management. Is that okay? And if we want to say in which areas does it differentiate from SKU to SKU regarding the OpenAI performance? Is it the rate limiting? Is it something else?
oh, this is a good question. A big customers that we're working with right now, I think that, let's say in most of the time, yes, it's quote, because GPU are still a very scarce resource. And in most cases, if you go with pay as you go and you're not buying the PTU ahead of time, a lot of these times, very easily, you're going to get to rate limit. And think of it, guys. This is even for the serverless. What if I want to not use Azure OpenAI? Like OpenAI found AI Foundation have a lot of other models that you can serve by yourself, but
Yeah,
try to go with a standard subscription and try to buy GPU for a month's time. It's going to be very hard to get it. This is
yeah,
also reflected in the serverless, and we really saw very big customer. It's a huge customer that was trying to find it, which means like he didn't got the enterprise subscription, for example.
yeah,
And he needed to create so many subscriptions. And think about it, they have like maybe over 50 subscription
yeah.
just to handle the production workloads. And again,
Wow.
in each one of them, and even okay, so you need to get the monitoring and the metrics,
Yes, yes,
and you need
yes.
to handle quote limits. How are you going
Absolutely.
to do it if you have 50 subscription and over 100 deployments?
Oh
Wow.
my God. Who's gonna manage it, huh?
Yeah,
All right. Remember, guys, Eilad session is also recorded. You can find it in YouTube in case you want to see it. At least me, I'm going to watch it again. Thank you so much, Elad, for your
thank you so much.
presentation. It is a pleasure meeting you, and I hope we can see you in another event. We will stay connected, of course.
Of
Have a
course,
great
and
one.
thank you, and it's been a pleasure. Thank you. Have a nice day, everyone.
Bye bye.
Bye bye.
All right. While we wait for our next speaker, we're going to have a small break and we will be right back. Thank you everyone for being here. Great. We have Patricia with us in our second stream. I'm going to welcome Patricia in a few moments. Just want to tell you guys the title of Patricia's session is Battle of the Titans, Azure AI Language versus Open Source Solutions. Very interesting sessions. Again, the first sessions yesterday and today are really exciting from our amazing speakers. Welcome, Patricia. Thank you so much for being with us today. We can't wait to hear about you and your session. I'm Konstantinos, and it is a pleasure meeting you here.
Hello, thank you very much. Can everyone hear me?
Yes, we
Yeah,
can hear you.
perfect. So first of all, thank you very much, Konstantinos, for organizing this incredible online event, Azure AI Connect, which I am taking part, and I'm really excited about it. As Konstantinos said, I am giving today's session called Battle of the Titans, Azure AI Language versus Open Source Solutions. And I am Patricia Rodriguez Vaquero, currently data specialist at My Data Works. And if you are a bit curious about me, here you can scan this QR code and it will redirect you to my LinkedIn profile. So you can just connect with me or ask me some questions after the session, or just ping me up there. And here just some summarization about who am I. Basically, as a curiosity, I love traveling, and I have done an Erasmus in Finland, so I really love meeting people from different cultures, and that's the reason, basically, that I have actually friends all around the world. I love pizza and some other stuff there that, such as that I am a nature and animal lover. So here I have structured the session with an introduction, and then I will introduce also the concept of Azure AI language, then some open source solutions, conclusions, reference, etc. But first, let's go on the objectives or what I had in mind while I was, organizing this session and preparing it. So basically, this talk aims you, the people that are on the other side of the computer, to provide you a comprehensive comparison between Azure AI language service with some other popular open source natural language processing solutions, like, for example, having Face, Spacey Library. And at the end, my idea is that we will be exploring and covering some key factors such as the performance, scalability, integration, cost. Obviously, here, the open source NLP solutions apparently or at the beginning they won't cost anything, but if you want to integrate with other solutions, they might cost you the infrastructure and everything, right? And also about customization. And at the end, my objective, it was to offer you the strengths and limitations of each approach. So, some summarization, okay, so you will gain an understanding of how both tools fit into the different tech stacks, and also the trade-offs between cloud-based and self-hosted AI. So, as I was introducing first, here's the agenda. I will make a little introduction, then we will cover in Azure AI language service, then some open source solutions, also with different examples, practical cases, and so on, some conclusions that I have reached, and of course, the references that I have based all the material for today's session. So, right, talking about the introduction, Azure AI language, basically what it provides us is an enterprise-grade natural language processing. It's a service, right? That offer us the scalability and integration, and also some pre-trained models for tasks like sentiment analysis, entity recognition, and many more that we will be covering later on. And at the end, what it makes AI adoption easier for businesses, and this is really important. On the other hand, we have open source natural language processing solutions that empower also developers with the flexibility, customization, and in this case, cost effectiveness. And at the end, it allows those developers to create and innovate and have full control of their solutions. And also here it is relevant that while cloud-based services provide convenience and manage infrastructure, so it's all in the service provides you with different solutions. Open source alternatives offer this transparency and adaptability without the vendor lock-in. This is really interesting from that point of view. And here it is really important to understand the trade-offs between both approaches in terms of scalability, costs, post-integration when you are going into production, and also the customization and personalization in general. And all of these characteristics are going to be crucial for selecting the right solution for your specific case. Here I have put a comparison table because I really like, to visually see a comparison with different factors. For example, in terms of performance, I have put here that Azure AI language is really high performance, and we are also taking advantage of a cloud-based AI solution. While, for example,
Patricia, I'm sorry to interrupt you. We are seeing your presentation in the first slide. Is this correct?
no. Okay. It should be the.
Yes.
Okay. Right now you can see it.
Yes. You can switch to slideshow, but if it is better for you like this, leave it like this. Whatever is better for you.
Like this, you cannot see? Yes, you can,
Yes,
right?
we can see it. We can see it. But
Okay, okay.
okay, thank you.
Okay, no problem. So basically, as I was saying, right, we have different factors that I've considered that they are important in terms of while choosing going with Azure AI language service or maybe choosing an open source solution. And in terms, for example, also of integration, of course, right, Azure AI language service it is it integrates seamlessly with other Microsoft ecosystem services. And for example, in this case, open source solutions might require custom integration with other applications, but that doesn't mean that they don't support a wide range of platforms and frameworks. For example, you can use, of course, Python libraries, TensorFlow, PyTorch, etc. In terms of the costs, we will cover in this at the end also. Azure AI language services, it offers you a pay-as-you-go model. This is really how basically Azure works with their different services that they provide. And of course, the open source solutions, they are free to use. In terms of, for example, the ease of use, Azure AI language is low code or no code options are also available. So what does it mean? Basically, we have an studio where we can just, like try and we won't be needing to use code, even though there is a specific library that I will be covering that it will allow us to of course write some code and try different approaches using Azure AI language service. So this is just for you guys to know and to have like a summarization table that might help you while choosing the right solution depending on your business case and so on. Okay, so introducing the Azure AI language service, it's basically a cloud-based platform, and it is designed to help businesses and developers integrating different natural language processing tools and capabilities into their different applications. And it is a part of Microsoft's AI services, which provides also pre-built and customizable models for, in this case, analyzing text, extracting insights, and also automating language-based tasks without requiring really extensive machine learning expertise, and so on. Here, I have just put some screenshots. And basically, to start using this service, we would need to go to Azure, to the marketplace. And what I am doing there is just, searching for language service. And we will be creating, in this case, the present tier, as we can see there, it's, like 1,000 calls per minute. Okay, it's the tier S. We will be creating it, and this is what I was saying before, that we have this language studio that it will allow us to try different models and to upload, for example, some documents that we will be wanting to classify, or do some summarization of text, translations, everything from this great portal, which is the Language Studio. This table here, I have got it from Microsoft Official's documentation, and basically, I think it's a really comprehensive comparison of some possible cases that we will be facing, of what do we want to do, and also the document format, and the best approach or the best solutions for our case. And for example, right, if we want to extract some main topics, main ideas, or relevant phrases, we will be going, or the best solutions to use is a key phrase extraction. While, for example, if we want to determine the sentiment and opinions expressed in a text, in a document, we might use better a sentiment analysis option, right? Or, for example, we have several documents and we just want to summarize them into different smaller texts, and so on. We will be using, like the summarization, the solution. Here also, I have put another table. As you can see, I really like to have everything summarized in one site, and here we have different features of Azure AI Language Service, like for example, what it is best for. So it is best for, in this case, tasks like text classifications, translations, entity recognition. All of these we will be seeing also some cases for them. Sentiment analysis, summarization of documents, and for example, the multilingual support. This service supports different languages for translation, and it works quite very well, actually, with different languages. And also, right, the ease of use. This is really important while starting trying or using a new service. So this basically what Azure AI Language Service provide us. It's an API that we will be calling. We will be just be required to pass an API key, and we will be ready to go to do the task that we would like to do, right? In terms of cost, we will be covering later on. And for example, also talking about the output type, this at the end, if we are using, as we will be using Python or any other programming language, you can at the end, right, structure the output that you are getting. But by default, Azure AI language, it returns us a structured JSON responses with different predefined categories. Okay, so right now, talking about open source NLP solutions, at the end, I put here that they have revolutionized the AI landscape, and what it provides developers, even researchers and businesses, is with powerful, customizable and cost-effective tools for, at the end, processing human language. And this is really important. And of course, right, unlike proprietary cloud-based services, open source NLP frameworks offer transparency, adaptability, and they are community-driven advancements. And at the end, all of these make them a preferred choice for those who are looking to build specialized AI applications. Here we will be covering, or we'll be seeing mainly these two different libraries or open source frameworks, such as Hugging Face, which is like an open source repository with different models and different solutions. And I have put also here, right, in case you don't know, a little description. So basically, as I was saying, Hugging Face is the most widely adopted library and offers a state-of-the-art and pre-trained models for tasks like text generation, sentiment analysis, translation, and different tasks. And also it provides access to different transformer-based models such as BERT, GPT, and T5, right? And then on the other hand, the Spacey, it's a fast and efficient NLP library, and it is designed for production use. And it features with also here pre-trained models for entity recognition, part of speech tagging, dependent parsing, and text classification, and many other tasks. Okay, so right now, the first demo that I wanted to introduce is name entity recognition, also called NER. And this is just a subtask of natural language processing that involves identifying and classifying entities in a given text into predefined categories. So as we can see here, this is the first example, but in this case, we will be using Azure AI language. So what we are using is this library here that we will be needing to install, Text Analytics Library. And what we will be required, it's an endpoint, so the API of Azure AI Language Service and its correspondent API key, okay? And then we'll be just calling this method, Azure Key Credential, and Text Analytics Client in order to just get the credential and the client. This is just, I have faked a document. This we could be connecting and reading a PDF document or a Word document and so on. But in this case, I've just hard-coded a little text, and I will be trying to extract different entities, okay? And as we can see here, right, this Azure AI language service automatically, without me specifying, not even specifying the different categories that it must search, it was able to identify several entities. Like, for example, here we have Microsoft Corporation, we have also Bill Gates, we have here also technology, Richmond, and so on. And it is not only able to recognize different entities from this text, but also the categorization where that word or words belong. Like in this case, for example, Microsoft Corporation, it is the category that it's been recognized is organization. And if it would detect a subcategory, it will appear here. In this case, it is not detecting any subcategory, right? And this is also really interesting and relevant that we are able to get also the confidence score. So how precise is this entity recognition process? And for example, here it is detecting the entity Redmond, the category is location, and in this case, yeah, it is actually also detecting the subcategory, which it's city, okay, with a confidence score of 0.99. So this could be really interesting, and it could help us, for example, when we are dealing with um, databases that are graph-based databases, where we will have nodes, and we will be able, right, in just a matter of seconds, to have maybe an idea or of how many entities compose this text, and we will be maybe it will be easier for us to generate that graph-based database, or another approaches that we will be needing. On the other hand, we have Hugging Face, and here this image is basically me that I am downloading locally this model that I am putting here, and I'm locating it in this local folder. And what I am basically doing, it's the first thing that we want to do and that we need to do is to install the library, right, in order to use the model. These are the different entities that it will be able to detect. So it will be person, ORG, organization, LOC, location, MISC, it's other name entities, and here you can see also some different examples of it. And also in the code, we will be needing to specify the different aggregation strategy. So that's why, that's the reason basically that I have added also here this table, right? In our case, we will be choosing the simple aggregation strategy, but there are different ones. So going on, this is, as I was saying, once we have pip installed or installed via Conda the library transformers, we will be using the model that we have downloaded locally previously, and we will be ready to go. In this case, we are just using the same text just for comparison purposes, and then we see that in my case, right, I am using a CPU. My laptop, I don't have a GPU available, but that doesn't matter because it will work anyways, and it is able to also recognize the different entities. You can see here their correspondent categories: organization, Microsoft Corporation, Bill Gates is a person, Redmond is a location, and also the different confidence scores, or so we see that it is pretty accurate in this sense. On the other hand, I am also showing the same. For the same case, we will be using a Spacey library. Here you can see that you can just install it like this, pip install, or if you are using Conda, Spacey transformers library, and this is just a model that I will be using, and I am just downloading it previously. And here, okay, something relevant about the Spacey library, it is that it is not possible to get a confidence score for our models, right? So for this specific task, the model doesn't expose these confidence scores, and we are not able to directly extract them and use them right out the way. However, of course, it is possible to train, in this case, a SpanCat model, which can report those confidence scores. So here we are just importing the Spacey library. We are loading the model that we have downloaded previously locally, and we are passing the same text, right? As we can see, in this case, the Spacey solution, it's recognizing the different entities. So also this it is doing this quite good. So the Microsoft Corporation is still right an organization. Bill Gates is a person, and so on. But we won't be able to get or to see the different confidence scores as previously. Now, after these examples, we will be covering sentiment analysis. And this is just, like, well, it is also known as opinion mining, but I have always saw it as sentiment analysis. And it's a technique that it is used to determine the emotional tone behind different phrases, behind a text, behind a document. And it is really useful. It helps at the end identify whether the sentiment expressed is positive, negative, neutral, and this can be really interesting. So if we are, for example, able to extract from a chatbot some kind of traces or logs, it would be really interesting to be able to analyze the sentiment of the user. If it's a customer service, to see if the service that we have provided to the user or to our clients are positive, are negative, neutral, and so on. Again, right now, we will be using Azure AI Language Service, and as previously, we will be just connecting exactly to the same endpoint, and we will be using the same API key. And here we have different one text with different sentences, and we want to analyze each sentence by its own, and then and get also the overall sentiment of the whole text. So we will be extracting the different sentiment of each sentence and overall of all the text. So the overall sentiment is mixed, of course, because I have put it here different sentiments, right? So for the first sentence, for example, I recently stayed at a luxurious beachfront resort, and my experience was absolutely amazing. So this, of course, the sentiment is positive, and the confidence score is 1. There is no doubt that the sentiment can be neutral or of course, negative. And this is what we are doing with all of the different sentences. Okay, so we can see also another sentence, for example, here. However, the Wi-Fi was a bit slow at times, which was slightly frustrating, and the sentiment here, the sentiment detected, is negative, and the confidence score is here -1. So we are pretty sure that this comment, our client wasn't happy about the Wi-Fi service in this specific example. And on the other hand, talking about Hugging Face, we will be doing the same task. So we have the same exact text composed by different sentences, and we want to analyze the sentiment found in each of them. Okay, so for that, we will be first downloading this tokenizer, okay, that it will be needed in order to then run the sentiment pipeline. And the results that we are getting is the first one that we were just for comparison purposes. That was this one. I recently stayed at a luxurious beachfront resort, and my experience was absolutely amazing. So in this case, the label is positive, and the score is 0.99. So we are pretty sure that this person had a nice stay at the resort. Okay. Now another task, NLP task that we can do is text summarization, which it is just a technique that is used to generate a shorter version of a long text. And at the end, the idea is preserving the key information or the relevant information, and also the meaning behind the document, the text, or the file itself. And here we will be using Azure AI language service again. And as we are doing text summarization, I have hard coded here a much longer text comparison with the previous examples, just to see if in this case the language service it's able to summarize it in few sentences. So this text is just about artificial intelligence, and it's talking about also healthcare and the businesses and how they are leveraging AI, and some of the challenges that AI can have, and so on. And as we can see here at the end, it is extracting a summary, which basically is saying that artificial intelligence is a rapidly evolving field that enables machines to perform tasks, and also other answers that we are getting as a result. And this is really important to highlight also that, for example, if we are connecting to Azure OpenAI API, and we try to do the same, or to mimic the same case with it, all the answers all the summarizations will be different, but using this service, the answer will be, or will remain always the same. Okay, so now talking about the same, a text summarization task, but in this case, we are using the Hugging Face open source platform. And then what we are getting here out of this quite long or quite medium text is this summarization, and is basically outputting that artificial intelligence is a rapidly evolving field that enables machines to perform tasks like that typically require human intelligence, and so on. So we are seeing that it also it's working pretty good. Now, another example of another NLP tasks that we can do is a key phrase extraction, and also known as keyword extraction. And it is just a technique that it is used to identify the most important words or phrases, depends on the length of the document or the files, and they capture its main topics or themes. So again, starting from Azure AI language service, in this case, we have this document that is talking about the stay at the hotel in Paris and their experience, and also some other information about the experience of this person. We want to extract the key phrases that the language service was able to detect automatically, without us indicating anything or giving any further instructions in this case. So as we can see here, we got these key phrases, such as, for example, luxurious 5-star hotel, striking view, Eiffel Tower, that the language service consider that they are key topics or relevant information out of this text or this review of this person. On the other hand, using an open source solution such as Spacey, the first thing that we are doing here again is downloading the model that we will be using, and then we will be loading it, and we will be using, of course, also for comparison purposes, the same text as before. So as we can see here, we have the different key extractions, right, or key phrases found in this text. Now, trying to do the same task, but in this case with this library that I didn't know, but I will put it in the references. We will be installing the Jake library like this, and here these are the different parameters that we will be needing to pass it to, in this case, the keyword structure method. So first, the language the language of our text or document file or whatever, and then the end parameter will be just the number of words per keyword, okay, and then top 15, it will be the number top ranked keywords found in this case in this text. So the key topics or main words extracted are, in this case, recently stayed, luxurious 5-star, that it was also appearing also with the Azure AI language service, Eiffel Tower, and so on. Now talking about language detection, it's a task that identifies the language of a given text. So it is used also in different applications like multilingual chatbots, search engines, and other social media analysis. So this is really important, for example. So if we have a chatbot solution, or we have developed a chatbot solution, so if the user or the person that is using the chatbot is asking some information in Japanese, the system, right, or the chatbot, what it's supposed to do is to detect the language the user is using and answer in the same language. So in this example, using Azure AI language, we have different sentences in this case, and some of them will be in English and some others in French. Okay, so basically we will be using the language service, and we'll be able to analyze each sentence. So imagine, for example, here that we will be having a document, and the document we will be having different paragraphs with different or mixed languages. So we will be able to analyze each sentence by its own, okay, and extracting the different found languages within each sentence. And we will be also be able to get the confidence of how sure we are that in this case the first sentence, which is yesterday I had an amazing experience at a French cafe in the heart of Paris, it's English, which with a confidence of 0.97. In this case, we will be also using this other library, open source library, which is called LangDetect, That here is just for repetitive tasks and to ensure consistent results. And we will be using this for teach to seed. And here we have the same sentences, and we will be able again to analyze each sentence and detect which is the language used in those sentences. So for the first language, as before, we are detecting that is English. But for example, the second one, I'm not gonna read it because I am really bad in French, but I think that from my high school lessons, I think this is French actually. So this is what is being detected here. Okay. And also we have this other nice library, okay, which is called Langdit, and it's pretty easy also to use. So we have the different sentences here, and we will be just iterate through them and classifying them and detecting the different language. So we can see here with the same sentence from this example that the detected language for this case it's English, so it is correct. And for the last sentence, it's detecting that it's French, so that also seems good to me. Here, talking about the costs, okay, so as I started saying, open source solutions directly they don't incur in costs, so they are cost effective. But in this case, the language service, you need to pay, of course. I am just this table. I have got it from official Microsoft documentation, and it's just a part of it for me to explain it a bit also. And to say that if someone wants to try this service, it's important to say that usually Microsoft offers a free alternatives, free tier, which will allow you to perform different tasks. Some of them we have covered them, such as, for example, sentiment analysis, key phrase extraction, language detection, and so on. So here we will be having 5,000 text records for free for each month. So if we just want to try the service and get a comprehensive overview of the different tasks and the power solution that the language service of Azure is, I recommend to use the free instance. And in my case, I was using this one, which is also not so expensive, the standard one, okay, and the features are actually the same ones, but here you can just see the prices for each million of text records. So the prices aren't so crazy in this sense. Okay. So just to summarize or some conclusions, what I try to show here it's basically that the Azure AI language at the end it offers a solution that can be scalable. It's easy to integrate with different Microsoft services, and it is enterprise grade, secured and backed by Microsoft in this case, right? It all of these characteristics makes it an attractive option for those companies that prioritize managed services and reliability. And on the other hand, we've seen some open source solutions that in this case they provide us flexibility, also transparency, and the cost that we are incurring is they are free and ready to use, right? So this at the end of the day allow us to customize different solutions and community-driven innovation. So here the question of which one to use. At the end, the choice that you will be going with depends on your needs. So I'm putting here, if what you require it's a plug-in and play solution with enterprise support, maybe I will be recommending Azure AI language. So because it would be a best fit for your case. But if you are, for example, seeking for more control, lower costs, and adaptability, maybe going with an open source solution instead will be the best fit for your case. And as a summarization here, or the main one of the main key takeaways from this session is basically that there is no one size fits all approach. This means that maybe also using or considering to use an hybrid strategy, which will be leveraging the strengths at the end of the day of both solutions, might just the best solution for you, because at the end what we want to create are solutions that are adaptable and that are also scalable. And just to finalize here, I have put it some references, okay, that you can just go there and check also the different models, as I'm putting here, the Hugging Face site and other repositories that I have been using in order to generate these cases. Just to finalize with the session, right? Here I'm just putting you a screenshot, which is it's not up to date because right now we are not only 8 members. I think we are like 46, so on. Right now it's a bit stopped because the root guardian.
Patricia, I'm sorry to interrupt you again. We are seeing your comparison table in the PowerPoint. If you're uh, displaying something else, I'm just letting you know that we are seeing the comparison table.
And right now,
Yeah, and right now we can see the QR,
okay,
the
but
Microsoft Techie Girls Group.
yeah, okay. Yeah, I
Oh,
was basically explaining, talking about this group that I
great,
have.
great.
But yeah, this was the end of the session.
Okay, I'm sorry to interrupt you again. Oh, I'm sorry. Are you done?
Yeah,
Have
yeah,
you
yeah.
concluded?
Hmm.
Okay, great, great.
Exactly.
Uh, Again, thank you very much for being with us today. Of course, everyone is able to watch the session again, every session of Azure AI Connect again in YouTube. I know we have the yesterday not that many streaming viewers, but we have a lot of viewers afterwards. So yes, thank you so much. Can we have the full presentation? Okay, someone is asking whether we can have the full presentation. And yeah, the video is going to be live on YouTube, Mr. Spiros Aluros. I don't know if Patricia can share the presentation. Patricia, is
Yes,
something.
yes. Um, I can
Can you
let me.
add it in your GitHub or can you share it later and I will post it in the
Yes, I will.
YouTube?
I will send it to you if you want. Yeah,
Okay,
of
perfect.
course.
Perfect. Yes, Patricia will send it to me and I will provide the link in the YouTube stream so you can access it, everyone. So thank you very much, Patricia. Have a great one. We will definitely see you in another event of ours the soonest.
Thank
Have
you
a
very
great
much
one.
to you.
Bye bye.
Bye, 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 everyone.
All right, that was Patricia. A very interesting presentation touching open source. We're going to have a small break as usual. We're going to have a video. Let's grab some coffee, some water, and we will be right back with our next speaker. Thank you very much. Yeah, I'm sorry. Again, we are going to have a small break and we will be right back. Thank you. Welcome back, everyone. We have Aaron with us. Uh, we are continuing with an amazing stream of sessions. I was saying in the other stream how grateful I am that every speaker has delivered amazing sessions, and I'm sure Aaron, if I'm pronouncing it correctly, will be deliver also an exciting session elevating cloud security with AI, and it is about DevSecOps. I know everyone will be excited to hear more about it. We are in the cutting edge technologies right now. DevSecOps quite important. Let me bring Aaron in the stage. Hello. It is Aaron or Iran? I'm sorry, am I pronouncing it correctly?
It is a run. It's okay.
Iran.
Thank you.
Okay, it is Iran. Okay. Hello, Iran. Welcome. It is a
Hello.
pleasure to meet you and connect with you. Thank you for coming into our event. We're honored to have you with us. DevSecOps, right? Quite an important, how can I say that, technology or I don't know how to name it, but I've seen it all over the place in the last 6 months at least.
I
I'm
will
sure
say methodology.
methodology. Yes, that's very that's the best. Yeah, the best term that I can think of. And thank you for that. I'm sure you have to say a lot about it. So without further ado, please share your screen if you are ready for it, and I will bring it in the stage.
Of course, I will do it right away. Can you see my screen?
Perfect. We can see your screen, and the stage is yours, Iran. Thank you very much.
Thank you very much for having me. Hello, my name is Eran Bibi. I'm the co-founder and chief product and technology officer at Firefly. At Firefly, we are helping cloud teams to get better control over the cloud by having an automation and AI layer that is helping to manage all of the configuration in the multi-cloud landscape. Before that, I was the head of DevOps and SaaS platform at a cybersecurity company, Aqua Security. And in general, I'm more than 20 years in the industry, focusing on infrastructure, and in the past 10 years, mainly focused on cloud and cloud native technologies. And with this session, I will elaborate about the DevSecOps methodology and how AI can help by showing a few examples of a usage of generative AI, and give you some of the tips and tools to show how you can integrate Gen AI capability in order to make your pipeline and infrastructure delivery workflows in with better security by using AI. Before deep diving into the subject, I just want to share something very creative. If you would like to see how DevOps tools look like humans, you can scan this barcode and see a very nice blog post where Firefly team show your favorite tools as human being, of course, created by AI. So if you're interested about that, feel free to reach out to the Firefly blog. So if we are talking about what AI can do, and I think that the topics that I'm presenting here is just the tip of the iceberg, because the AI landscape is evolving very fast, and every week there is a new tool and a new method and a new LLM capability that can unlock new opportunities. But if we are overviewing the basic stuff that AI can do for the cloud practitioners, we can think about predictive analysis that you can basically streamline log output and application output into AI and ask for analytic and assessment. You can also embed chat bots within your knowledge and short the cycle of getting knowledge between teams by allowing the chatbot answer for you. Also, AI is very good for coding. There is specific models that are really excel on that domain. So generating code and manifests is something very straightforward. I'm not talking just about application code. I'm talking about infrastructure as code and policies code and Kubernetes manifest and stuff like that from the ecosystem of the DevOps. Help with monitoring and alerting, documentation, knowledge share, as I mentioned, and of course, embed AI in the quality assessment of the pipeline. This is also one of the items that we see teams doing recently. If I'm focusing on the DevSecOps world, more related to how to embed security and security finding in the shift left before deploying application and infrastructure into production, we see a very good evolution of having security finding as something that most probably you didn't know all of the findings that you have due to the lack of tooling. And then there was a very good generation of tools like CNAP and CSPMs that are giving you better visibility about what happened in your cloud and cloud native workloads. So you are getting notified and getting alert. And then we see in the next step of the evolution that those findings are streamlined in an automated way into the relevant teams by opening tickets, Jira integration, ServiceNow integrations, and making sure that findings are being addressed in time. And in this phase of the evolution using AI, we can see the AI remediation come in place. So it's not just about finding the alerts, it's also about creating fix and automated fixing for security concerns and misconfigurations. So the AI remediation is something that we see now being very popular. And of course, this is something that is possible due to the capability of the Gen AI tooling. So if we're looking about the current tool set, specifically that Microsoft offer, GitHub Copilot, bringing you the Gen AI capability into the IDE. And of course, GitHub Copilot is not the only tools in that specific space. Cursor, Windsurf, another type of tooling that is helping engineer using Gen AI to be more efficient and boosting the productivity. But also Gen AI is being embedded in other services in the cloud like Kubernetes and in the cloud management. And in overall, we can see that AI is almost in any type of product of the DevOps and the cloud operation ecosystem. So we see tools like Datadog and New Relic, IAC tooling, DevOps lifecycle tooling like RNS, PagerDuty, and even Firefly become focusing on AI and how AI can help cloud practitioners to embed and use the advantages of AI in the day-to-day to make stuff more efficient, automated, and self-healing, of course. So if I'm talking that very nice theory into the practical way of using Gen AI, and again, I would like to focus on really the basic stuff, not the complex stuff. I'm not talking about um, agentic methods and the next level of the items that you can do using AI, which is truly fascinating. But focusing on the basic stuff, that stuff you can do even today using an AI. So because when you're managing cloud nowadays, everything is declared as code. The infrastructure is declared as code, configuration files, the CI/CD pipeline, and the policies. Everything that is code, you can either analyze or generate code using AI. And I think this is the essence of unlocking the possibility of embedding AI within your DevSecOps pipeline. And I would like to show you a few examples that is very easy to understand and easy to even implement starting today. So let's see a few examples. So I'm going to share my VS Code. And in this VS Code, you can see I have a Terraform manifest. So that specific Terraform manifest is something, if you don't familiar with Terraform, Terraform is a declarative language to describe cloud resources as code, very popular IAC framework. And what you see here is a sample of, I will say, um, not secured template of Terraform that is creating few resources in the cloud. And what you see here, access key and secret key, of course, those are fake. So don't worry about that being shared in this presentation. And this is intentionally a bad example of Terraform, an example with few misconfiguration and some security concern. And just by overviewing those, if you are familiar with best practice, you can figure out there is some of the stuff that not supposed to be here, or at least not aligned with best practice, not aligned with security best practice. So what I would like to show you how is it to take this code snippet, use some AI chat interface, and chat interface can be your favorite tooling like Copilot, ChatGPT, Claude, Deep Research, anything that is accessible for you. And by using a simple prompt, analyze this manifest and understand what are the security concerns, and of course, suggest a fix and a remediation for that. So before doing that, I will just share a disclaimer that will say, if you are using AI, make sure not to send any private data, any corporate data, any something that is sensitive, unless it's a private model or you have the clearance from the security team to share data. So what I'm going to do in this example, I'm going to use a prompt that I would like to overview together with you that is making the LLM model security expert and doing analysis for that code. So I'm using a basic prompt engineering technique here to make sure that the prompt is detailed and give me the desired results. So what I'm asking is, act as a senior cloud security expert specializing in infrastructure as code. I needed to perform a comprehensive security review for the following Terraform configuration for AWS. And I'm pasting the code, and for the analysis, I'm giving you an explicit requirement. I would like him to identify the security issue in the code, classify them, explain them, provide a specific recommendation for each fix, and include a sample code showing the secure alternative approach, and giving more guidelines for the response to be clear, professional, with executive summary, detailed findings, and remediation checklist. So let's check it out. I'm going to copy this prompt, and I'm going, for this specific session, I'm going to use Claude, but you can use any type of AI that you have a secured access to it and you feel comfortable sharing your Terraform template. So this is the prompt, and what I'm going to do is going to upload and attach the main TF that I just showed you. And within a few seconds, I'm getting an security assessment report that is giving me the key findings. So let's go over it. The key concerns include exposed AWS credential in plain text, which is of course very bad, public access sensitivity in the S3 package, overlay permissive security group in the IAM policy, unencrypted storage, sensitive data, hard-coded secret, and weak password. And what I see here, because my prompt was explicitly saying give a code snippet and fixes, I can see either the severity, what is critical, and recommendation of how to fix it. So I can go over and really understand what is wrong with my code snippet. And again, this is without using any security scanning. There is a very good security scanning for Terraform manifest, but this is just showing you how AI can also analyze and understanding what considered to be not secured, and also giving you the remediation step. Remediation in that specific case will be giving you the fixing the actual code and the actual resource block to be more secure. And I see the high severity, unrestricted security groups, recommendation, public accessible database, and I see here the flag that is publicly accessible equal to false. The hard-coded database credential, which is very problematic. There is the why, of course, if you want to know the reasoning for that. And recommendation, taking that from an SSM parameter, which is a secured location. And the medium severity, I will not go over everything, and the low. And of course, I have the remediation checklist to make sure that I'm actually addressing the issue that was found in that specific manifest. And I see the immediate action, which is addressing the critical, and I remove the hard-coded AWS credential, handle the S3 bucket, the IAM policy, making sure that everything is not publicly accessible, and so on. So what I can do as a follow-up prompt is please provide the new version of the main TF with all of those issues resolved. And what I will get with this prompt is that Claude will generate my main TF with all of the finding resolved, making sure it is secured and saved. What I will do, of course, is review it and use it instead of the bad example that I previously showed. Very nice. And while this is a chat interface and it's not something you can automate, all of the LLMs have API access, and those kind of checks you can embed within your CI/CD pipeline, making sure to have an AI scanning in your pipeline. And if you need someone to review, you can have that flow, and I will demonstrate such flow using the Firefly platform in a few minutes. So let's see another example of what you can do. So we talk about infrastructure as code. I would like to show you something a bit different, but also highly related to the DevSecOps examples. So second here. Okay. I have these workflow files. This is a GitHub action. A GitHub action that is doing a Docker build of a dummy application, of course. This GitHub action have some security flaws. And by reviewing it, I might not notice there is some issue, or at least not notice all of the issues that I have here. So let's use the same method, not for IAC, but for my actual pipeline. It can be my Jenkins file, it can be the GitHub action, Azure DevOps, any type of pipeline. And what I will do, I will use this prompt as a DevSecOps expert specializing, I would like it to act as a perform a comprehensive security audit. And it's very similar to the previous prompt that I'm used, but it's just more tailored for CI/CD scanning. Let's see what is the results here. So I'm using that, and I will upload my workflow file. So let's start with the executive summary. I found 2 critical issues, 3 high severity, 2 medium, and 1 low, and the hard-coded credential in the workflow. Of course, this is not the best practice of using secrets in a CI/CD file. This is the recommended fix for it. The fact that I'm using SSH access using the root user, and there is some reasoning behind the risk and the potential impact. High severity issue, disable the SSH host key verification. So some of the items I even like a human will not even notice that are being problematic, and I'm not sure there is a very good scanner that will able to let me know about those issues without the using AI. The fact that I have a security scanner here, I'm using the Trivi scanner, which is highly recommended to scan each time you are building a container, but I'm not blocking in case there is a security risk. So this is something that the AI figure it out, and of course suggest an exit status change to make sure the build will be blocked if there is finding from Trivi. And no tagging strategy for my container. I'm using the latest. It's not recommended. And some low severity issue about the pipeline. So you can see here the remediation roadmap, what I need to do right now, short term and long term, and this is regarding the severity. And of course, I can ask, please create a new version of this pipeline with all of the issues installed. And my chat interface, in this case, Claude, will generate a new GitHub action with everything that he found basically mitigated. So those are 2 examples of how to take something that is declared as code, either IAC or a CI/CD pipeline that is declared as code. I think most of the CI/CD pipeline today, even Jenkins, are using files that the AI can show. And in this way, you can use the AI and the LLM model that is available in your organization, of course, only after verifying it is secured and safe to share data, as an AI DevSecOps analyzer for getting assessment and remediation and the new version. So let me give you another quick example of how Firefly using the same method in order to resolve and remediate security findings when we find misconfiguration on cloud resources. So this is the Firefly dashboard. I can access the governance screen. The governance screen is showing all of the policies and compliance check across the frameworks that can be SOC 2, PCI, HIPAA, and other type of frameworks. So what I will do here to show you in the example of the remediation is to go to the critical severity. And then, for example, I see one of the policies are SNS topics is publicly accessible. This is considered to be a critical. And I have 66 SNS topics that are basically violating this policy is basically violating those assets, and I can click AI remediation. So the AI remediation in this case, because some of the resources are created manually without IAC, and some of them created by IAC, meaning the fix supposed to be in the Terraform module, in the Terraform manifest. So I will use the IAC patch. The IAC patch will identify the IAC that is responsible for creating those SNS topics that are misconfigured due to the public accessibility and fix them in an automated way. So after selecting, this is all of the IAC templates that are associated with the resources that are misconfigured. Let's check one of them for the example and click Review Fix. So what happened right now is basically we taking the code, the IAC code in this case is a Terraform code that is responsible for the SNS topic, identify the place where the SNS topic is mentioned as publicly accessible in this principal block. It's asterisk, and now we are basically changing it into the least privilege concept and narrowing down only to the actual principle that is needed, uh, um, so it will not be publicly accessible. So that was done using the AI remediation capability. You can click pull request and it will issue a code fix that of course need to be reviewed by someone that but one of the reviewer of the application. And if everything is okay, this is the changes in the file. If everything is okay, you basically have a fixed code that can fix the remediate the issue on the cloud. So I'm going back to my presentation just to wrap everything up. So what are the key takeaways from this session? So you can use AI as a security scanner. Of course, you need to make sure that someone will review and approve the findings and the remediation that is suggested by AI, because not all of the response are perfect. You need to make sure that the prompt that you are providing is accurate using the prompt engineering principle, making sure to have the best prompt that you can generate for that specific task and change the prompt for each type of scanning that you would like to do. It's not going to replace security teams, at least for now. It's not fully automated. It's not like the best of class agent that is finding, fixing, remediating, and applying to the cloud automatically without any humans. We will be there, I guess. But as for now, we still need to make sure that we will work together with AI and not make the AI doing all of the jobs for us. And don't be afraid to try to integrate AI. If you have a safe access to module, a private module of Azure OpenAI or other type of organizational LLM that you have the permission to use in your CI/CD, you can use AI as one of the checklists, one of the step in your pipeline. I see customers doing that even today. Thank you very much.
Hello. Thank you, Iran, for being here with us. I was speaking without adding myself to the stage. We were very grateful to have you today, and we hope we will see you again in another event of ours. Have a great rest of your day. Thank you very much. Bye bye. Hello again, everyone. I believe we have our speakers with us. David Lorenzo and Mario Arias are here. Uh, Allow me to ask them if they are ready to start, and we will be right back with you. So just hang on, please, and I'll be right back with you. Give us a moment. Great, thank you for waiting. Let me add David and Mario. Hello,
Hello,
my friends.
hello.
Hello.
How are you?
Hello, everyone.
Very well, very well. Thank you.
Very well.
I have
Fine.
to say, uh, very grateful for being here with us today. I bet your presentation is quite interesting. Let me rephrase the title. So we're going to hear about Copilot using Azure AI Search. We have a quick chat yesterday with David,
Yeah,
and he kind of explained to me it was what I'm suspecting to hear. So I'm very excited to hear your case, guys. Let me know if you want me to keep you both on the screen, and I'm going to share David's screen. Is that correct?
yeah, that's correct. Yeah, I will share the presentation. We will be both on the screens and we will be changing the
Perfect.
mic from one to another.
Perfect. Again, everyone, welcome David and Mario. Guys, the stage is yours. Thank you very much.
Okay, thank you, Constantino. The first of all, I would like to thank you and all the sponsors for being this event to be possible. We started like some months ago with this event through the MVP teams, and I think most of us are giving talks today and this week in general. So congratulations for the event. We are happy to be here with all the community from Azure AI Connect, and we are proud to present our today's session in which we will explain a little bit how to boost or extend your Copilot Studio with Azure AI Search to increase um, the knowledge sources experience from the standard one that Copilot Studio provides to a more powerful one using Azure AI Search, where you can control all the chunking on all the information that is returned from Azure AI Search to Copilot Studio. So not too much introduction, so I will start by presenting myself. I am David Lorenzo. I work as a Power Platform lead in Procware, also doing some architects task in the Power Platform world. And yeah, I have some certification. As you can see in the screen, I am Power Platform Architect, Fabric Analytics Engineer, and Azure AI Engineer. And also I am Microsoft MVP since the last summer. So this year will be the first time on Seattle if everything goes well. So I'm very excited about this. And that's my contact social network, just in case I am more active on LinkedIn. So prefer you contact to me through LinkedIn, it will be better. And my colleague Mario Arias. Mario, tell me about you.
Hey, thank you, David. Hello, everyone. My name is Mario Arias, and I'm the head of hyperautomation and AI at Procware Spain. And I'm certified as an Azure AI engineer and hold all the certification in Power Platform, with the solution architect certification be the most notable. And I am MVP too, and that's all, David.
All right. So let's start
Okay.
by talking a little bit about the past, not?
Yeah, before the advent of generative AI, the process of building topics for conversational AI was manual and time consuming. And the dark teal area on this slide represent the time spent on hand building topics, which other led to missed opportunities due to conversations being missed or scalped. The red area highlights this missed opportunities, showing the limitations of manual topic buildings. The slide illustrates the challenges faced before generative AI. With manual topic buildings, we were unable to keep up with the dynamic nature of user queries and content changes, resulting in a less efficient and effective conversational AI systems. But now, David, what have we gained from generative AI?
Yeah, that's correct. So after generative AI, we changed how conversational AI works. And you can see on the screen that now we spend a lot of less time building, hand building topics. You can see on the gray area that is less, it has less width than the before slide. So we spend less time building hand building topics, and they are more powerful topics. So with generative AI, we get a more powerful conversational flow with the user. And then on the green area, you can see that in difference than before generative AI, now uh, all the conversation that goes out of the hand building topics are not missed opportunities. So with generative AI, we can get the user to a conversation that ends up in a opportunity, in a lead, in a customer satisfied with the conversation, and then we can end up with a sale of our product, and that's what the customer wants in the end. So we can see how the chatbots has been changing this past 2 years after generative AI boom. And then we will see today a demo of it where you can see all the potentially that it has. Okay. So in summary, now with the revolution of conversational AI and Copilot Studio, we can build more powerful assistant in less time, reaching a level of value that was previously unimaginable. So this way, we spend less time building, more time thinking about the features, and then we get a more powerful product with less effort, and we will get more sales, and we are more efficient than before. So how we can take a decision. So there is a lot of products in the market, in the Microsoft environment. But Mario, how can we get a decision of what to use in which case?
Yeah, we'll take a quick look at the different types of Copilot offerings and how they can address a range of business needs. Okay, first we have Azure AI Studio, which provides a robust platform for creating custom AI solutions with your own data and user's interface. Next is Copilot Studio, which gives you a SaaS-based approach to build generative AI application quickly. Then for those who need ready-to-use solutions that leverage existing data, Microsoft 365 Copilots offer built-in AI capabilities for everyday productivity, while Copilot for Sales and Copilot for Finance focus on industry-specific tasks, integrating seamlessly with CRM and ERP systems. And lastly, Copilot add-ons for Microsoft 365 allow you to enhance your Microsoft environments with AI-driven features tailored to various workflows. Today, our main focus will be on Copilot Studio and its extensibility, exploring how you can leverage it to build powerful, customized AI experiences. And next slide, David. Copilot Studio really opened the door for creating specialized AI components we call agents. For example, imagine a traditional copilot as a skilled co-driver in a car who provides navigation and general support for the entire journey. Now, picture agents as individual experts at different stations in a pit stop. One handle fuel, another, I don't know, manage tire changes, and another check the engine, wherever. Okay, and all working quickly and efficiently to optimize performance. In just short time, this concept has evolved from a one-size-fits-all support system into a network of specialized agents, each fine-tuned for a specific task, offering a much more dynamic and scalable approach. So, David, could you tell us more about the spectrum of agents we have available today and how they can fit into our workflows?
Yeah, of course. That missed to translate the top phrase, but here is what are the Copilot agents. This is in Spanish. Yeah, the Copilot agents are AI assistant that can help optimize business process and improve productivity. But there is three big areas of Copilot agents currently that they are from simple in the left-hand side to more advanced in the right-hand side, as you can see in the slide. So starting from the simple ones, we have the retrieval agents, where they retrieve information from company data, from reasons, summarizes, and answer user questions. Okay, that's a little bit what we are showing today, and we are in the middle of retrieval and task. So we will show an agent later on that is capable to do hotel reservations. Okay, so and also is capable to do to show information about destinations, to show nearby restaurants. So it is capable to retrieve information from external systems. Among they are Azure AI Search, and also is capable to do some tasks, but they are tasks that we tell him to do. So we are not reached yet to the autonomous agents. So the task agents takes action when requested, automates workflows, replace repetitive tasks for users, but then we are not reached in this example. We are building since approximately November or so. We have given this agent more and more features over the month, and now we can consider that is in the middle area of task agents, and soon it can get some feature of autonomous agent. Autonomous agents operates independently, dynamically plans, organize other agents, learns and scales, but it operates independently. Is the more important phrase in this description, and that is a feature that we have not yet introduced to this Copilot Studio Hotel Reservation Assistant, but that we will do it soon. But for the most important today, we want to show you how we do tasks and how we do retrieval, and from this retrieval we can boost the knowledge source using Azure AI Search. That is the main topic of the speak today. So now we swap and go into the Copilot Studio architecture. So that's a very big diagram, but it's not so easy to explain. So we start from Dataverse. Dataverse serves as the database for the Copilot. It allows us to introduce the solution concept. You can see the dashed line here that wraps all the custom entities, pre-built entities, custom topics, plugin actions, cloud flows. So all these components that compose the Copilot are inside a solution, a Dataverse solution, that allow us to organize the items, the components of the Copilot, and also introduce the concept of ALM. So ALM is the concept that defines how we move, for example, among others concepts, how we move this copilot from one environment to another. So as it is inside a solution, is you can see a solution like a box with a lot of products or components inside. So you can move the box from one room to another. So you can move the solution from one environment to another, and all the components will move inside. Another thing that Dataverse allow us is to introduce the airbag security concept, so role-based access control, which allow us to introduce or securize the access to the copilot based on roles. So all Dataverse, you can in Dataverse you can register new roles. You can assign that roles to different users, and so you can control who access the copilot, who can develop and who can use it, and that's very important for getting control access to the copilot. Okay, inside the different components, we have entities. Entities are concepts that allow us to parse from the different conversation inside the copilot, parse things like names, address, or credit card numbers, or countries or cities or so, and then you can use that entities to contact or to manage the different topics and the different conversation flows that your copilot must do. Then you can use cloud flows, you can use actions to connect to cloud flows, to use custom connectors. We will show you in the demo some custom connectors that are very interesting. And through cloud flows or through custom connectors or through standard connectors, you can reach to more than 1,000 system just by plugging that connectors to the cloud flow, to the copilot, and then using natural language to describe what every action should do, what input and output parameter means, and so on. So you can orchestrate using generative AI, using, you can see that row to Azure OpenAI, Azure AI Search. So you can extend the copilot to these Azure systems in order to add more and more functionality. And then here the sky is the limit, because you can plug another external system to Azure OpenAI, Azure AI Search. On the down left corner, we can see Power BI icon. So in Microsoft Dataverse, there is usage information that keeps logged in every Copilot usage, and then you can make reports, Power BI reports, to show that information to your users, to your technicians, to your managers, and then take a decision based on information about the usage of your chatbot. And then we have on the top side, on the top row, we have some Azure service like Microsoft Entra ID, where it is used to do the authentication and authorization and control the access to the Copilot. Then we have Azure Bot Service, where we can extend with bot framework skills, just in case we have old-fashioned framework skills developed, they are not lost. We can incorporate to Copilot as skills, and we can use it to extend the Copilot. And then we have also a very interesting feature like data loss prevention policies. This is a preview feature, but it's very interesting to control who can use what connectors can be used by the Copilot and by the different roles, and to allow to avoid the data loss in your company. And finally, we have the channels. So the channels are the different system where you can publish your Copilot after you developed it. So you can test on the Copilot Studio interface, but then you want to use it outside. That's normal. That's the last step where you publish the Copilot to Slack. You can publish to Teams, to Facebook Messenger. Soon you will can publish on WhatsApp too. You can publish to X and a lot of more channels, and all that channels are just 2 or 3 clicks far from get your Copilot published on that channels. So it's a very powerful system. We have explained a little bit of the architecture of the internals of the Copilot. If you have any doubt, you can put it on the comments, of course. Then now we will go into explain a little bit more of the process we have followed to fill the Azure AI search in order to use with this Copilot, and then what is the components that our demo will have in order to show you before we go into the demo. So Mario, where you are ready, you can start explaining.
Okay. Very interesting, David. The explanation is very prevailing. Okay, and before diving into the complete demo architecture, let's take a closer look at one of the key agents in our system. Okay, Azure AI Search plays a pivotal role in Copilot Studio by enabling more sophisticated and context-aware retrieval of information. Okay, and instead of merely matching keywords, Azure AI Search relies on semantic understanding, making an essential component for systems that require intuitive discovery of rich, dynamic content. Okay, and this is particularly valuable for projects dealing with extensive and often unstructured data, where direct keyword searches may fail to capture nouns or context-specific information. Okay. One prime illustration of this approach is a Python script. Okay, THUIS could just as well be an Azure function designed to scrape webtenerife.com, and this script automatically gathers description of the island made activities such as hiking routes, water sports, or cultural excursions. And however, these initial descriptions are frequently concise and lack a captivating tone, making them less useful for end users. Okay, to resolve this script employs GPT through Azure AI Foundry to enrich the scraped text, and GPT add depth, clarity, and engaging style to its description, transforming sparse outlines into compelling narratives that highlight unique selling points and interesting details. Okay, by infusing more context and refinement, GPT ensures that the content resonates better with users, whether they are tourists, local, or service providers. Okay. Next, come to the text embedding small model, which generate embeddings. Embeddings are numerical representations capturing each enriched description's semantic meaning. This step is fundamental because it enables a content-rich method of categorizing and retrieving data. Rather than relying on precise keywords matches, Copilot Studio can leverage these embeddings to find relevant content based on underlying concept and relationships. Okay. After being enriched and embedded, the enhanced descriptions and their corresponding vectors and stored it in Azure table. Okay, keeping all relevant fields in centralized location ensures that each piece of enriched text, along with its semantic vector, is readily available for future processes. And this comprehensive storage approach lays to groundwork for more robust and easily maintainable data pipeline. Okay. And finally, the agent create an index with a dedicated field for vector search, elevating the platform's retrieval capabilities to a new level of precision. Okay. Azure AI search ability to work with semantic vector means users can look for activities or information based on conceptual relevance rather than limited keyword matches. This entire pipeline from scrapping to enrichment and vector indexing underscore how Azure AI Search significantly amplifies Copilot Studio potential and enabling it to serve richer, more accurate, and context-aware information to users. Okay. And the next slide,
Okay.
next slide. Yeah, and the next slide, before we jump into the live demo, let's walk through how we structure each part of this trivial agent. Okay, as mentioned, the Python-based scrapper we discussed early gathers and enrich information from webtenerife.com, generating embeddings that fit into Azure AI Search. This form one of our core knowledge source, ensuring that Copilot has detailed, easily searchable data and local attractions. Okay. Beyond that, the trivial agent also integrates seamlessly with Dataverse, which we're using as our PMS, the handle critical hotel operations. And this includes searching for hotel availability, finding the best offers, and confirming reservations. Okay? Each of these functionalities is managed by specialized agents within Copilot Studio. So the user only needs one interface to manage the entire booking cycle. Okay? And the system can also tap into external APIs for real-time weather updates or location data, rounding out the full trip planning experience. Okay, with this understanding of the architecture in place, I'll now pass the baton to David, and who will show us how the travel agent works in action. David,
Let's go to the demo time.
let's go to the demo.
So we switch over the presentation, and yeah, here is the Copilot hotel reservations. Okay, so starting, we can start by showing a little bit all the functionalities. We have time, so we have at least half hour yet on the presentation, so we can start by okay, we create a simple agent here. We added a name and a description. These two parameters are not important for the functionality. So this is the first parameter that are important on the functionality. That are the system prompt or instructions that all the message forth and back are following. So you want to add here only general instruction that must be followed in each interaction. Okay, not a specific features instruction. We enable orchestration using generative AI. This is very important because if you don't enable that, the magic doesn't happen. Okay, and then we have down there the knowledge source. So that's where we introduce Azure AI Search. You can see here the icon. You can add knowledge from public websites, from SharePoint. So public websites are simply URLs that are being indexed. That's important because in the back, Copilot Studio is using the Bing API to to get information from that public website. So if it is a website where Bing doesn't have access, it doesn't work. Okay, you can use also Dataverse and SharePoint, and then on the advanced, you have the Azure AI Search, which is where we connect all the Azure vectorized index. This is very important. If you create an usual index without vector fields, it doesn't work. So here, the Copilot Studio is doing a vector search on the Azure AI index. So you have to use a vector index. Mario, maybe we can prepare for the end step, if we have time, to show the Azure AI Studio, the Azure AI Search Index. If you can prepare the browser, maybe we can switch the screen in the end.
Okay, I can try.
Um,
Okay.
yeah. So after we have the knowledge source, we have also the actions. If you remember on the last slide that Mario was explaining, we have all the actions here that compose the hotel reservation process. So these are the get hotel by zone, get location coordinates, get zones, search nearby restaurants, and so on. So all that actions are, I want to go into one of them, for example, get hotels by zone. And here is very important um, to describe with natural language, but with a specific instruction, not too much description, not long descriptions, but a concrete one like this. So list of hotels filtered by zone, search hotels by zone. So our concrete phrase that describe what this action should do, and then with each input parameter, in this case there is only one, which is the zone, which we state that Copilot Studio should pick up this parameter right from the prompt, right from the conversation. So it will use the magic of the generative AI to get it and push into the action. And then we describe what this parameter is identified. So we identify as a city, which is the city is an entity. We see that in the Copilot architecture diagram we see before, and then gets out a leaf filtered by a specific zone, city, province, country, area. Then on the output parameter, we can add also these descriptions and what to do on this action. We can check another action, for example, here on the search nearby restaurants. We use this action to find nearby restaurants over a specific long latitude and longitude coordinates, and inside a specified radius in meters. So we have as input parameters the latitude, the longitude, and the radius, and then we output the places, right? So the places in the description are the restaurants. It's not needed to add a lot of phrases, a lot of text in each of the boxes. It's more important to be specific and concrete. So let's do a quick demo. One thing important about the settings, I won't be into every one of these sections, but one important thing you want to check is that generative AI check is marked here, and then yeah, you can go forward. There is no needed to configure like a service principal for authentication, as we are adding Azure AI search using a connection string. There is no need to configure service principal here. So you can see that it's authenticating with Microsoft, and then it will work and find Azure search results. So let's go and try it here. So let's put I want to go holidays, and let's, very important, in order to debug the session, that you enable this open activity map, and then also you can switch on the track between topics. Okay, so now I want to show you also, just a moment, because if you remember the diagram, we are using Dataverse as the hotel PMS through the interface that is going through the Power Automate flows. So in Dataverse, we have all the information about the zones, about the hotels, about the hotel prices, and then on the last step, we insert the reservation into the Dataverse. So it operates like a hotel PMS, a property management system. And then we can see here all the zones. We have given up the Canary Island. If you have not visited them, I recommend you to do. But yeah, we are giving this information, and as you can see, it is returning that information on the action get zones, and the Copilot Studio are just writing as a response. And then it prompt that I have to decide. So what is my preferred destination? So of course I want to go to Tenerife. Why not? It's a beautiful island. So we can, yeah, so it is now searching about Tenerife, and then it finds 3 hotels. If you go to the hotel zones, to hotel sections, it shows Hotel Alabama, Hard Rock Tenerife, and Meliá Jardines del Teide. You can see them here. Let's put selection Hotel Alabama, and then I want to search for availability. And now it is using adaptive cars. Just in case you want to use, I recommend to visit the adaptivecars.io website, go to designer, and here you can push new car, and then you have some templates here to start with, and then you can use the data format and the template here, or the different forms here, in order to build your own adaptive cars. We have used some of them here. You can see, to show the hotels, to show now a form in order to find check-in, check-out dates. So let's go to from the 13 until the 16. We are 3 paxes, and then let's search for hotel offers, and then it show you the prices, right? So we are from the 13 until the 16, 3 paxes, room only or bed and breakfast. But yeah, let's go room only, because I want to take the breakfast on the cafe down the hotel. So it's, you want to complete the reservation? Yeah, I want to complete. And then now I get a summary of the reservation. It is autofilling these fields because I am logged in with that user here. So I have configured this to autofill with the logged in user, but of course you can change it. Let's put a mobile number and then confirm the booking. Now what is going through Power Automate and inserting the reservation into the Dataverse. So if we get the localizer and go to the hotel reservation table, we should have, if everything is going well, we should have the reservation, in fact, and then we have the 13 until the 16 for 3 packs, and room only for 50 euros. All my data status confirmed, and then we can go and take a look of the hotel Alabama that we just reserved. Now we have a reservation, but I want to know what things can I do around the hotel, right? So let's put what activities can I do nearby. And now it should take the conversational context and then go through the knowledge source that we have and find the correct knowledge source that give us information about Hotel Alabama, which is in Tenerife. If you remember this diagram, we have some knowledge source. We have Web Tenerife and Gran Canaria. If you remember, Mario explains that we have uh, web scrapped Web Tenerife through a Python script, enhance the description user Azure OpenAI, generate the embeddings, and insert into a vector index in Azure AI search. So that's what's happening here is that is taking information about that search index. You can see now if in the end we will show the index in Azure AI search, but you can see here that if we click into the first, you can see here like it's like a JSON format where we have the description, we have the partition key. This is, of course, can be improved by Microsoft. It shouldn't show all this raw information here. But yeah, for the moment, we are seeing that it is using the Azure AI search in order to extract the information here and just is using that chunk of information that is relevant for the Rich Carlton Alabama. That you remember that we reserved the Hotel Alabama. It is a Rich Carlton Alabama is the full name, and it is if I just giving the phrase what activities can I do nearby, it takes the context of the conversation. It knows that I am just reserved the Hotel Alabama, and then it goes into the Azure search index and find Alabama or things to do nearby Alabama, and then show it here. Let's push another one. You can see it is information related to Hotel Alabama. And another interesting thing that is happening here is that the index information is in Spanish, as you can see here. This is Spanish language, but it translates on the fly because we are talking in English and show you the information translated in English for you. So that's another important thing because you don't have to maintain the information in the data source in all the language, but the Copilot Studio will translate it on the fly for you and for your users to improve the user experience. So that's very interesting. And yeah, we can take a look. If we reset the conversation, we can take a look another knowledge source. We have 15 minutes yet. So we can take a look. If you remember the diagram, we have also Gran Canaria. This knowledge source, if we go to the knowledge section, you can see here that Azure. So we can see here that Tenerife knowledge source is connected to Azure AI Search with a vector index named Actividades Tenerife, so Tenerife activities. We have 120 document count. We have 2 megabytes of storage size and 2 megabytes also a little bit less in vector index size. So that's where you can see that the Azure AI search connection is correctly configured. And here we describe what this knowledge source is intended for. And then if we close and go to the another, you can see that the type of knowledge here is public website, different from Azure AI Search on the Tenerife. So if we go to this knowledge source, you can see that we plug in a website URL, and then if we ask what activities can I do in Gran Canaria, then it will use this knowledge source in order to answer your question. So instead of going to Azure AI Search Index, now it will use the Bing API to return a description, a composed description from the grancanaria.com website. As you can see here, if we click on the links, it goes directly to Gran Canaria website. So that's where you can combine different knowledge source of different types. You can use your Azure AI search in order to control the chunking of the information, in order to control more granularity. You have more granularity in which information you expose. So if you put a URL of a website, you expose all the information from that website. But if you control the index section of the information, like we have done in Azure AI Search, you can control what information is exposed to the Copilot. And of course, you can increase the accuracy of the information using semantic search. You can add skill sets for different approaches. That's more a topic of Azure AI Search. But of course, what we can show you today is that you can plug Azure AI Search to Copilot Studio using a vector index, and then you can have all the power of Azure AI Search into your chatbot using Copilot Studio. I don't know, Mario, we have ready
Yeah,
for showing.
yeah,
Okay,
I'm
we need
ready.
the help of Konstantinos. If you are there, just you can share the Mario screen. Just because we want to show the Azure AI search configuration that we have done for this
I
space.
think that, yeah. Um,
Absolutely.
yeah,
All
When it
right.
is ready, I will do that.
yeah,
Okay.
I'm
Okay.
ready.
Perfect.
I'm ready. Okay, sure. But um, I don't
Okay.
know.
In the meantime, I want to show you another feature that we have not shown today yet. That is this custom connector feature here. We have integrated another feature for the travel agent that is based on a specific place. You can find nearby restaurants on that place in a specified radius. For example, we want to go to Hotel Alabama, so we can you find restaurants
Okay, David, sorry.
nearby?
You can see my screen now.
Let me see. Yes, I'm adding it in
Yes.
stage.
Yeah. Okay. Okay. You can see my code.
Yeah,
I will remove David's screen so I can
yeah.
add your screen.
Just a moment, please. And then just to explain the last thing here,
Ah.
and then we
Okay.
switch to Mario. Just you can see here that we are finding restaurants nearby Hotel Alabama in Tenerife in a 4 kilometers radius. Then it will use this is a technique that is called dynamic chaining, because as you can see, it is using two of the actions: get location coordinates first of all to translate Hotel Alabama Tenerife to coordinates. That's one of the integration we have done with the custom connector to Google Geocoding API. And then with that coordinates is using the second actions, which pass the output parameters from the output from the first action, the latitude and longitude, is passing as input parameters on the second action, and then is converting the 4-kilometer radius I typed in the chatbot to meters, and then is calling this search nearby restaurants from location action, and then is returning that JSON with all the information, and is then constructing the response. As you can see here, it is a nearby restaurant that if we open the Google Maps link, it goes correctly to the restaurant. So that's another interesting feature. It's not the main topic of this discussion, but it's cool to show you that also. Now, yes, let's move to Mario's screen, and then he will explain us how the Azure AI search is configured and the index things. Yeah.
Okay, thank you, David. Yeah, very quickly. This is the code of agent. Okay, and this is the steps of agents. Is a Python, and the process. The first part of process is scrape categories. The second part is generate embeddings. The third part is upload to blob storage, and finally save to table storage. Okay. Blob storage is not necessary, but is additional step. Okay. Okay, the first step is script categories is a function, and the function go to the webtenerife.com. This is website, okay, and search different or find different categories: food and drink, sports, other activities, okay, nature or whatever, okay, and it's important because the descriptions are very small. Is not I don't like, and every description need more details, and for adding more details we're using the GPT 4.0 mini, I think. Yeah, maybe yes. And is in this part. When finish the extraction of different categories, the second step is in the batch manner. I process the different batches for enrich the text and obtain more accuracy description about the categories. Okay, and this is the code. It's very long, and I don't have more time for this, but the important is the concept. Okay, and process, extract the information, enrich the categories with GPT, and the next step is generate embeddings. Okay, generate embeddings. It's important because it's the key. It's the part of generate semantic information with embeddings of OpenAI. Okay, and it's very similar. It's a specific code and with different optimizations. Okay, it's not important the details. Okay, and the final part is save to table storage. Okay, and the process is okay, extract and find different categories in this page, and generate enrich text, generate embeddings, and save to table storage. The result is this table. Okay, in this table we have different columns: partition key, row key, timestamp, ID, name, description, link. Description and link is not important, and is the reason for is empty. And description detailed. Okay, this is original description. Only Escuela Español para Extranjeros. This is a school for foreign people, and description detail is more detailed description. Okay, it's more enrichment, more complex, more more accuracy. Okay, and the final is content vector. Content vector contain every dimension, every semantic dimension of the description. Okay, it's very, very, very low. Okay, and this is the storage. Next step is go to the Azure AI search. Okay, this is my Azure AI search, and the first step is add my data source. Okay, Azure data table, activities, data source. Okay, it's the same table. The next step is create index. Okay, my name index is actividades Tenerife, Tenerife activities. Okay, and Tenerife activities, when I configure, I can create indexer. Okay, the indexer is the engine for the index. Okay, and it's possible activate indexer. Okay, for example, in this case, for generate the translate your data source into the index. Okay, when you use this indexer, create a job generate operation. If the operation is correct, the data translate into the index. Okay, and if I find the results into my index, if you want, you can see different names of the fields. The name of the fields in the index and the name of the fields in the tables should be the same. Okay, it's important, but this field is special. Okay, is special because it's not a string type or integer type. It's a single collection. Single collection is a special type of data for a vector content. Okay, and it's important because you first create a vector profile, and you should configure algorithm and vectorizer, and it's easy, but it's very long, and it's very specific for configure this part. Okay, but when you configure this part, you have the all fields, and you configure this specific field, a star indexer, and you can search your own data in this searcher. Okay, it's very interesting because you can see different fields, and the most important field is content vector. Content vector is I don't remember the dimensions, but I think that
1536.
500. Yeah, it's a very big dimensions for every details of the descriptions. Okay, and if you see other view, because it's very, very big, I can disable this view. Okay, only for the presentation. Okay, and all of data of my table is in this index. When the index is finished, when the data is in the index, Copilot Studio is available for import or for search in this index. This index doesn't have limit for it doesn't have size limit. It's doesn't well, the money is the limit. Probably the money is the limit, but it doesn't have a theoretical limit of size, and it's very powerful because Copilot Studio is a powerful engine, but they have a limitations because it's normal. It's low-code tool, and it's normal because the size of the fields are a limitation. The paths of the websites are a limitation. And if you combine agents and Copilot Studio and AI search, you can obtain the most powerful agent or agent engine that you want. And that's all, David.
Yeah, it's very interesting. We want to show this configuration because it's maybe the most difficult one. So Copilot Studio, okay, for us is more like step by step, or you can play with the description.
Yeah.
But this is more difficult, or maybe more distinct to configure, and it's cool that we can show to the users. As you can see, all the information is in Spanish, but Copilot Studio translated on the way, on the fly, when you ask. So that's cool, not having to maintain different translation of the information, just in case you are good with the on the fly translation that the generative AI is doing, of course.
Yeah. Yeah.
And yeah,
Okay, David,
some of
you
the
can
some of
share your
yeah,
screen for
yeah,
me.
please, Konstantinos, share my screen again.
Yeah.
We are going into the finish. There is one question on the chat that we can have the slides. Of course, we will share the slide with Konstantinos, and then I don't know if they will be shared with the audience, or just in case, Spyros Salouros, you can reach Mario or me through
Yeah.
LinkedIn, and we
Yeah.
can
Yeah.
send you, okay, the slides.
Guys, you can share your information in the chat, and it
Yeah.
will be presented to our viewers. So whatever you want to share, you can do it in the chat.
Okay. Okay.
Mhm.
Uh, I want to join the chat. Connect. Let's connect with YouTube account.
Yeah.
Or you can add it in the private chat, and I will share it for you, if that's
Ah,
easier.
private chat. Ah, okay, okay.
Now,
yeah,
I have to
but
say,
I can't attach the slides here.
no,
So
no, you cannot.
no. Yeah. So okay. I will put my LinkedIn, just in case Spyros
Yes,
want
yes, that will be perfect.
to reach me, and I can share
Yeah.
the slides. No problem.
Uh,
Okay.
Guys, this was an amazing presentation. I have to say, I will re-watch it because it is very interesting. It is something that is quite extraordinary, and I was waiting a long time to see someone doing this integration with the AI Search and Copilot Studio.
Yeah.
Uh, yeah, I have so many questions, but you delivered a very challenging one, and you spoke for for such a long time, and now I understand why you were two. This is a hard session to deliver just one person. My only question is,
Yeah.
do we have the capability to add skill sets to our AI search
Yeah.
index?
Yeah.
We do have.
Yeah. We do
Okay.
have. So for example, the vectorization process, that of the embedding generation that
Yeah.
we have done in a Python script,
Yes,
you can do it directly through skill sets. For example,
great.
that's one of the features. It's a little bit, I don't know, I don't say difficult, but is not clearly states the step
Yeah,
by step in the documentation, but we have getting to do with a little bit of effort, and then you on the indexer process,
yes, yes,
then it will use that skill set that connect to Azure OpenAI. It is important that the Azure OpenAI
Mm.
is in the same region that the Azure AI Search. That's one of the
yes,
questions. If you don't have it, it doesn't work, but doesn't tell you anything. So
yeah,
that's a little bit great.
Yeah.
And
Yeah.
yeah, that's some of the features, but we have get to get it working. It's
Yeah.
not why we do how we do it in this demo, but we have get it working. Yeah.
Yeah,
yes,
it's good question because probably is the best way. But for me, for example, it's more easy create this this script in 10 lines probably is more easy
Yeah.
with Python, create embedding
Yes.
than with service, and it's more easy. But probably it's not the best way. I think that the best way is configure correct skill set into the Azure search, because it's more maintainable in the future, maybe.
Maybe. Yes.
Maybe.
Maybe.
I don't know.
Great. Great. Such a nice presentation. Thank you so much, David and Mario, for this amazing session. Um,
You're welcome.
I will
You're
stay
welcome.
connected with you, and hopefully we will see you in another event of ours.
Yeah,
Uh,
Of
sure.
course.
I just, Constantino, just switch to my screen, please,
sure,
because
sure.
I want to tell the audience that just in case they want to try Copilot Studio, they can just create a free account here, aka.ms/try Copilot Studio. You can try it there. It is free for a few months, and then you can start playing with it. And the last one, these are the blogs that on the left hand side is my blog, the right hand side is Mario's blog. We blog about Power Platform and AI frequently. And then, yeah, so just in case you want to stay tuned there.
It's in Spanish, but
It's
with
in Spanish. Yeah,
Copilot or GPTs, or it's
you
very
can
easy to
translate
translate.
using Copilot
Uh,
Studio, as you can see.
yeah,
Yeah.
Yes, yes,
The
yes,
last is thank you or gracias en español.
gracias.
Gracias.
yes.
Okay,
Gracias.
that's it.
Thank you
Gracias,
so much.
my friends. Have a very nice evening. Bye bye. Thank you so much for
Okay,
being with us.
bye
Bye bye.
bye.
Thank you
Bye
so
Thank
bye.
much.
you.
Thank you.